Hab drauf gedrückt.
Okay, eine Minute noch. Also, genau, da ist es.
Müsste, ja.
Passt, sehr gut. Okay, hello, ladies and gentlemen, to our exercise number 8. Today, we want to build up a small airplane for computational fluid dynamics with the ANSYS workbench. And it's the last exercise of our summer semester. And we come to our slides here. And the exercise is rather short, but you know, it's complicated. During the last lessons, we have learned a lot about the construction of airplanes. We've seen there are many different types of airplanes. Here in this picture, you see at least 4 different types of airplanes. Every airplane had another design, another age, and of course, the flying characteristics and the behavior is rather different. If we now look on the right side, if we compare different airplanes, for example, Airbus A300 with a Concorde or a B-70 or an F-40, you will see the drag coefficient is rather different, but also here the friction and the pressure resistance is also different. It depends on the geometry. And if we now look at the drift and at the drag, you also see the airplanes are rather difficult. And it's the same with the airplanes. Yeah? Here, for example, it's an Aardvark or a Raptor, and the design is rather different. The wings are rather different. And so you will get different drag coefficients and you will get different lift coefficients. And this is exactly what you have to do now, what we have to examine with our airplanes. To model the airplane, we will switch to the ANSYS workbench. You already know it. Here's our ANSYS workbench. And you know we have a toolbox here. We have component systems. And we have our project schematics. And now we want to use the tool for fluid flow simulation, so-called CFX. I just drag it on the project scheme, and I see here is our tree. We have geometry, we have the meshing tool, we have a setup, solution, and we have a results tool. And first, we want to construct our airplane. We go to geometry, and now please take care. Go with the right mouse button to right click and don't use space claim. We don't want to use space claim, just use the design modeler to construct your airplane. And I press the design modeler and hopefully it opens. That's time for some coffee. It takes some time. Okay, that was fast. So here again is our design modeler. You see we have our generates, our extrudes, we have our tree outline, modeling, sketching, and we have the graphics display. Enlarge it a bit and try to use your mouse. You can use the middle mouse wheel to rotate the coordinate system. You can use the mouse wheel for zooming. And now, before we start with our airplane, please zoom it to, let's say, 10 meters size. That's a good size for our airplane. Let's say 10-meter length. That's pretty fine. Okay, maybe we have to say some more words about this. Please make the wings not too large. Yeah, let's say 10 meter for one wing is enough. Don't make it bigger than 10 meters, please. Otherwise, the airplane will be too unrealistic large. Okay, now you rotate it to one direction. Let's say, and we start with the construction of our wings. The wings are the most important part of the airplane. You need the wings for flying, but on the other side, we now will start a classic design. But I've shown you during the lectures, you can also choose a more interesting design, or you can choose a more innovative design. I showed you these slides before, and you see there are a lot of different airplanes designs possible. You can decide which design you want to take. A lot of new designs are available, and you must not do the design in the classical way. You can find your own design. Look here, for example, are the wings at the back, and we have here at the front different wings, or even this one. You look there, even really crazy designs. Okay, so you can find your own design. But at first, for learning, we want to construct more classical design. Yeah, you choose your plane, and I would say choose a ZY plane here. And the first thing we want to do, we want to build up a good wing. You had the lectures about wings, about NACA wings. You already know what to do. And I just make a rough sketch of my profile. And let's say I start with 2 lines. This line, well, this. That's my first part of the profile, 2 lines. And then I need a bit more rounder designs, and I can use a, let's say a spline. Splines are perfect for wings. And go to open end to close your spline. And then I need, this wing is, this wing is pretty fine. Yeah, it will be a powerful wing that works. That's a bit crazy. Somehow a bit connected. So, yeah, that's always not so really cool, but doesn't matter. I do it like this. Okay, maybe you can find another design. And after you've made your rough design, or after you made your design of your NACA profile, you know you need a longer way over the wing. For higher velocities, you need a lower way under the wing. For low velocities, and then you will get a low pressure at the upper side and a higher pressure of the side below. And this gives you the force for lift. Okay, then we have to create an extrude. And please don't make it much longer than 10 meters. Yeah, I make it extrude, let's say 4 meters. And you add the material not only in one direction. Yeah, I can go to generate. Oh, that's a bit longer. Maybe 5 meters gives you some more power, bit more power. And I also want to edit not only normal, but both sides symmetric. And then you have your first wing. Yeah, you have both sides of the wings. Well, that's a good design of a wing. We can start with this design. And now we need our cockpit. Yeah. And to create the cockpit, you change to the settings. ZX plane. And let's say I want to make a round cockpit. Go to sketching, circle, start here somewhere. I make the body of my airplane like this. And again, I do an extrude. First go to generate and then to extruding. And then we extrude. And again, here we extrude in both directions. I first go to generate and I extrude in both directions symmetrically. And this is now the first body of my airplane. Oh, say it's a bit too big. I go to dimensions and I can add a diameter and then I can change it. It's 1.80 meters. Let's say 180. You have to sit inside the plane. So 180 is maybe not so bad size. Okay. And the next step is we need a nose. We need a nose for our airplane because, if we have this design here at the front, it will have a big drag coefficient and that's not efficient. So I go to modeling again, and here I choose an edge, and I insert a blend, for example. So the blend with a fixed radius. Right, and generate. Wow, that's not so really efficient. Let's make it a bit bigger. No? For example, 8. Yeah. Do you like it? Is it okay? Yeah. I think it's not so bad. And we add another blend or chamfer at the tail. The tail looks also a bit not so nice. And I go to, again, I choose here the edge. I add a chamfer, apply, generate, and this will give a chamfer. Now maybe we can change it a bit, say to 1 meter. No, it's not the right. I want to do this, and here 1 meter. Generate. It looks like this. That's pretty fine. Maybe say 3 meters here, and say 6 meters here. Huh? That's a cool design, huh? That looks pretty good. Pretty realistic. It's a nice airplane. Maybe I make the radius a bit smaller. $60. A bit better. Okay. That's the first design, but something is missing. I need here at the tail additional wings. And to do it, I choose the chamfer, maybe it's a bit smaller here. Right. Generate. And I add some additional wings here on the ZY plane. And now I don't want to mix it up with my main wing. And by the way, the main wing can be a bit bigger. I can change it again here by dragging. Make it a bit bigger. I'll give a bit more power to the airplane. That's not so good that I connected this. Doesn't matter. So it gets a bit more power. And this is, so this is at the back. It's not so really efficient here. I do it like this. Oh, that looks not so good. So maybe take care that you do not connect these 2 points together. Okay, doesn't matter. Oh, maybe we can add an additional design point here. Okay. Add another construction point here. Then I can also modify this by the additional construction point. Looks a bit, maybe a bit better. Oh. Huh. Okay, that's okay now. I don't really like it. Change it a bit here. Yeah, that's a bit better. Okay, you know, this design of the wings is a bit sophisticated. Let's do it like this. And then we come again, we want to do a new sketch here on our XY plane, on our ZY plane. Go to the ZY plane again. Here's our wing sketch. And now I add another sketch here with this new sketch button. And on the new sketch, I want to design the wings in the tail. Sketch it again. And let's say we make it a bit more easy. Yes. I make it just with lines. And I add a new extrude here. And that's too long. Let's do it only 2 meters. And extrude it in both directions again. So symmetric. So that's cool. And I need at least 1 wing for I use this XY plane. Let's look, now I have chosen the XY plane. And again, I do a new sketch in this XY plane, but I will do it a bit more simple. I don't want to use splines. I just take a rectangle. Rectangular geometry like this. I extrude it and generate it. And that's our okay, why not? That's our wing at the back. Maybe I make the extrude a bit longer. Maybe let's say 3 meters. And too long. Let's say 2 meters, 0.5. And again, this geometry is not really nice. I want to make a blend, for example, with a fixed radio. Again, here, this edge. And then it will look like this. And yeah, the thickness is also not really nice. It's too fat. have a lot of track. So I have to add a sketching dimension, and I add a vertical dimension to this line. Horizontal, so like this, and let's say 1. Generate, and again, same side. Huh? No. Okay, horizontal. Let's say 0.1 meters. And generate. So it's a bit smaller, huh? Again, smaller. Take care about one thing. Don't make it too small. We have to print it later. And if you print it, you can't make it too thin. Here, this. Let's say bit thicker. 7. 007. It's a James Bond number. That's a good size. So, okay. Our airplane is finished. Our airplane is finished. It looks pretty nice. It's a good design. It will fly. And let's look how much drag and how much lift we will get. So at least we have to, we don't want to model something inside the airplane. Our goal is to model the surrounding around the airplane. We want to model the air around it. And to do it, we will enter Enclosure. So go to Tools, Enclosure. Yeah, you choose Enclosure, and this Enclosure will generate here a ball. Take a spare or ball, and you add with, let's say, 5 meters, and we create a ball around our airplane. And with this ball, we can simulate the air. Maybe make it a bit bigger, let's say 10 meters. Huh? That's 10 is maybe too big. Let's say, don't make it too big. If you make it too big, you will have a problem later with your cells. You need some resolution at the airplane, and if it's too big, you will not have a good resolution. Okay, and please mind the direction. We have here the Y direction, and later if you define the boundary conditions of the air, you have to define it in the right direction. So you don't want to have the air from behind. You want to have air from this direction here in plus Y direction, in the green Y direction. Okay, this is our first airplane design. Don't forget to go to generate, and it's finished. You don't have to define any components or so. This is enough. Now you close the design modeler. Yeah, here's our slide again. You see design modeler, we have this green tick. So the design is correct and finished. And now we must do a meshing. We open our mesher, go to edit. Just take another coffee, drink some coffee, wait a bit, take your time. And the mesher will open after some seconds. Okay, and here is your airplane's geometry, but your mesh is not already generated. You can click on mesh, Make sure that you have solver CFX and physical preferences CFD. That's all you have to care about. Now you just go to generate. You have to wait for a while. And don't change too many settings. This is now the design of your model, and it looks pretty good. Resolution is okay. It looks good. Everything it should be all right. You just close it. And now it's time to save your model. Yeah, please, before we save it, that's always a problem with the Ansys Workbench. Your mesh is already finished, but the small flash does not change to the green tick. I do not know why this happens. It's always, I think it's a little bug. Yeah. So you always have to go again on update, and you have to update it by hand. This only happens in the meshing tool. With all the other tools, you don't have a problem. They will update automatically and you will see the green tick. But here with this meshing tool, you need to remesh again and have to wait for the green tick. Okay, but this is not a big problem. The green tick will occur because you already made the mesh. And now it's a good time to save your airplane. Don't forget to save it from time to time. And don't make the passes too complicated. Don't use any special symbols like Ü or Ä or any special national symbols. Just use your simple names. For example, airplane. Airplane or a number 001 or design 01. And that's all. And you store it. And please take care that there is no blank and no special symbol in the path of your model directory. Otherwise, the program will crash later. So please ensure that you don't use any complicated special national symbols here. This will always cause problems. And it's difficult. There is no really error message for this problem. So you just have to know it. Yeah. Now you can go to setup, edit, and just again, time for some coffee. You have to wait a bit until your tool opens. And it is here. Our small airplane is inside the bubble of the enclosure. And now, please, again, something I have to explain. Yeah, the screen looks a bit crazy here. The menu looks a bit crazy, but doesn't matter. It's just, I think it has something to do with my teams. Normally, this menu doesn't look like this. But anyway, we don't need it. Yeah, just don't look at it. You can go here on the model tree, and now you have two models. Yeah, and now take care. We have one model for the airplane. Yeah, that's the volume inside the airplane. It's this B10102. This is a volume of my airplane, and we do not need this volume. It is loaded here inside our program, but we do not want to have it. So we just don't use it. We want to have the other volume. We have the volume here around the airplane, the B221. So maybe click B102 or B221. These are two different meshes. Yeah, they look just the same, but we only want the surrounding. We only want to have the enclosure. We do not want to make any calculations inside the airplane. So we will have to go to default domain. We double click it and we just choose 102. Oh, no, we just choose 221. And then we have our and you see the menu changes. Yeah, all the other objects disappear. We only have our enclosure. Yeah, the plane now, you do not calculate the plane. Yeah. Now we can again double click here on the menu. We choose our fluid. The fluid is air, of course. Make sure it's not water or gasoline or anything else. We only want to have air with 25 degrees centigrade. That's fine. And fluid model, it's isothermal, it's K epsilon model. That's pretty fine. We just keep it like this. We don't need any other settings up to now. And then, yeah, maybe that can be something you can test later. You can maybe test the turbulence model. That's also something maybe for your presentation at the end. You can also maybe use another model and you can present it. You've learned all about this K epsilon model, but now, up to now, we just take K epsilon. That's fine. And now we must enter additional boundary condition. You just go to default domain modified. Take care, there is also a bullet point default domain modified default. That's, you do not choose this, just use default domain modify, right click with your mouse, insert boundary, and then we say, we name it opening, or let's say air, or yeah, or sky, or surrounding. Surrounding is a good name. And now we have to set surrounding to an opening, and we have to choose the surrounding surface. And you open this selection dialog with a button with the 3 dots. I do it again to show you. Location, go to this button. You can also choose it here, but that's a bit complicated. Just go to the button with the 3 dots to get the selection dialog, and then you can just scroll through this with the arrow keys and just choose the surrounding. Yeah, I don't want to choose the wings or something like this. Just want to have to search for it. Where is it? It's the first one. Okay, the first one. Now you have the surface of your surrounding. You go to OK. And don't forget, you always have to choose apply or OK here at the bottom. Otherwise, yeah, we need something for the velocity. You go to boundary details, and we want to define a velocity, and we take the Cartesian velocity components in U direction. Yeah, no, not U direction. U direction is wrong. We take the V direction because V velocity is in Y direction. It's always X is U direction, U velocity is X direction, V velocity is Y direction, and W velocity is Z direction. So you can remember it, X, Y, Z, U, V, W. That's the order. If we want to define a wind velocity in plus Y direction, so we have to take the V velocity. I go to kilometers per hour, and let's say how fast is it? Well, 400. And here we go to 0, and we go to 0, and that's all. Now these are our velocities. You see, that's just you made some errors to give you a hint where you have set the velocities, but that's pretty fine. And we can rename all the other domains to airplane. and the airplane, maybe change it to small, better. And in the airplane, we choose a wall, no slip conditions, that's pretty fine. Okay, now we're finished. More or less, we just want to set the solver control to 100 iterations minimum, apply it, and that's all. We can go to save, and hopefully now we have the tick. And again, I save here the workbench design one. I think it's important to save it from time to time. And please always save your workbench if you go to the next step, before you go to the next step. Sometimes it crashes during this if you change to the next program, it can crash, and that can be not so good if you have no backup. Okay, again, I go to solution, I go to update, small flash, and now the mouse wheel rolls, the program is running, and I want to look inside what's happening. I go to display monitors, and you see your solver is running. Yeah, it takes some time. Here you see, well, these are the iterations, but I can say CFX is pretty stable. I think you will not be able to get a crash, yeah, of the numerical simulation, because the program is really stable. Here again, you see the solutions, the residuals. You have the residuals of the mass balance. It's a red line. You have the residuals of the U momentum. U momentum is a momentum balance in X direction. And this is the Navier-Stokes equation. We solve the Navier-Stokes equation here for our enclosure. You've learned, I think it was go back, it was in chapter 4. I've taught you about Navier-Stokes equations and convection and diffusion. Maybe you can just look inside the slides, and we can have a short. No, it was another chapter. Yeah, the program is still running. Let it run. We have already 40 iterations. We have some time to go to the theory again. Oh, something with a net. Net is not so fast now. Just click again. There it is. This was a slide about the theory of the Navier-Stokes equation. You remember the different mathematic models I explained you. And we are now here in this screen. We have the convergence of the momentum equations here, and we have the convergence of the mass balance. And you can read the data that is shown in this XY plot can be already also seen here in this text file. In this out file, you see the convergence, and the it should be as narrow as possible. You should get values under 10 exponent -4 or -3. We have our momentum balance, our Navier-Stokes equations, we have our mass balance, and also the K epsilon turbulence model. A short look at the turbulence. I told you we decided to take the K epsilon model, and you can also see here's a convergence of our turbulent kinetic energy K. We have also a balance similar to the Navier-Stokes equation, and we have also the dissipation and our balance equation for epsilon, the dissipation of the turbulent kinetic energy. And now we get this small window here that everything is all right. The results are saved here in the RES files, and just click on OK. Maybe you can also check a bit here all the values, but I don't want to go too deep into detail because we have to read. And again, if your simulation ends successfully, normally you don't have to read the out files. But if some problems occur and the numerical simulation diverges, or if you have some bugs or some crashes, or if your hard disk is full, then there will come some error messages, and then you have to start to read and make a deep dive here on this out file. Okay, I close it. I close this also, and you see you have at the solution your green tick. Everything is fine. And now we can start our post-processing process of the results. Again, take your time. Don't click too fast and too much. No. What is this? Looks a bit funny, but everything's here. Okay, you just only visualize the edges and not the planes. But if you visualize the planes now, we can see the design of our airplane, the blue airplane. And now we can add some streamlines. The streamlines, we start from the surrounding and we add our streamlines. Maybe they are not so much. Maybe make some more so we can see something. And we see it looks pretty nice. It's exactly what we wanted to have. You see here the streamlines show the fluid flow around the airplane, but you see over the wings the velocity gets a bit higher. That means we will have a lift force. That's the most important thing here, this happening. Switch off the streamlines, and I want to have a look at the pressure fields. I go again to airplane, render to color, and I choose variable, pressure, and I choose local for the scaling and conservative. Go to apply. And this looks pretty nice. Yeah, you see your airplane. Of course, you have some drag from the front and some pressure here on the front, but doesn't matter. You have here this under pressure area at the top of the wings. And this under pressure area gives you a high force, high lift force. So your airplane will fly. And you have a high pressure region here below your airplane. And this will give you also additional forces upwards. So this airplane will probably fly. Okay, the design here is not so good. Gives you some drag force. Of course, we have drag force at the tips of the wings. And the biggest drag force is here, the nose. Maybe we have to change the design of the nose later. But doesn't matter, up to now, it will fly. To show you the forces, we can also add some vector fields. Location should be on the airplane. Here. And we should show as variable forces. Oh, that's a really nice picture. That's a really nice picture. You see the forces on your airplane. And to explain you what we see, we have here, yeah, of course, here are always some forces. They're more or less symmetrically, and we have also some forces here, some lift forces. Here at the tail, the forces go in each directions. It will not help a lot, but here in this low pressure region above the wing, we have a pretty high lift force. Yeah, and this lift force will help you a lot. Yeah, it will help you to lift your plane upwards. And please also look at the length of the wings. You should not make the length much longer than 5 meters. Yeah, I measure it. Otherwise, it will be too big. Of course, you will get higher forces, high lift forces if you make the wings longer. But if you make them 50 meters, it's unrealistic. And also, we can't print it. Yeah, we want to have the airplane more or less not. We do not want to have too long wings because later we will print it with our Ultimaker printer, and then the models will not be really good printable. Yeah, that's also something you have to take care about, that we can print it afterwards. Okay, this is our design, but now we need the forces. We have vector plots. We can estimate that here are big forces in a qualitative way, but we do not really know how big they are. And to get this information, we go to this function calculator here. Function should be here on the should be force on the airplane. And now we can give the direction. And interesting is the set direction. And now I go to calculate, and you will see we have about here 1.9 million Newton. So let's say 1,900 kilonewton lift force. And that's really cool. It's a high number. The airplane will fly. If it goes into set direction, yeah, make sure you take here global set direction, and that you make your construction that the lift is in set direction. And make sure it's a positive value, because positive value means you have a lift in upwards. If you get negative numbers with a minus, the airplane will go downwards, and then your design of the wing is not really good. Okay. Additionally, we want to show the drag force, and then we go to Y direction, calculate, and you see drag force now is about, it's the right direction, it's Y direction. Make sure you have Y direction, Y direction. Drag force is about 325 kilonewton. It's not so much, it's okay. And if you want to make this value better, a hot candidate is here the nose. You can make the nose a bit, you can change the design of the nose, and then you will get a better value. Okay, maybe we can do it. Let's look. Remember this, paint this here. I take these values, I just copy them to remind them. Look, this was our first design. Airplane design number 1. No? Okay, you have your forces. Say this is a lift force. And let's say this is a drag force. And now we change the design a bit to get a better value. Now I see the lecture is nearly over, but we can do this pretty fast. I just go to Design Modeler, and Wait a bit, it must open. And no, I don't want to do it. I will make it later. Wait a second, because it will take too long. I will show you how to do it in 1 second. Before I show you how to change the nose again to get better drag force values, I want to show you something that is really nice, because we have here the possibility to take another background. We can take an image. Yeah, we can take, for example, image of some mountains, and then we can here, it's falling down. That's not that's not the direction. I took the wrong direction. That doesn't look really nice. I want to change the background again. Maybe we can choose this one. Yeah. That's also cool. Now it's a spacecraft. It's also cool. Or we take another, also the east. Or we can define it by look again here. There's also the feature custom. Then we can load the image. I don't want to load it. I just take my background as it is, and then we can it can look like an aircraft outside or in a high altitude aircraft. Okay, that looks pretty nice, and I think we are finished with this lecture. You can now design your own airplane. Maybe have a short look how we can better design of the nose. Go to geometry, edit geometry, in the design model. And now I have to, the enclosure. I'm not really sure if the mesh will change automatically. Here, if I take this enclosure, but we will test it. I will want to change this blend here and change it a bit. Let's say to 6. This will be worst. 8. No, this is not good. I want to delete this blend. And I want to have chamfer. I will delete this, but I'm not sure if it's possible to add this after. Let's look. We tried. Apply, chamfer, generate. Yeah, you see the enclosure will not really change, but doesn't matter. We can do this afterwards. Maybe a bit more. The nose. It's too. Oh. Okay, 2. Here I want to have 6. That's nice. That's a nice design. And maybe additionally, I will add a small blend here. Yeah. Wait a second. Uh, I, I, I add a small blend with a fixed radius. Yeah, 0.1. Generate. Yeah, that's a bit made the design a bit better. Yeah, that's a cool design. That's a cool nose. Maybe we can also add some blend here. Not really sure this works. Okay, but yes, this will also help a lot to have a bit blending here in this region, and maybe also here. I add some blends. No, I don't want to add some here. Or maybe I add a blend here and here. This was a bad region for us. I add a bit blending here. Okay, I think this will help also a bit to have a bit better design. But now you see the enclosure will not be changed if you change this design features. Yeah, the enclosure is still in the old design. So I delete this enclosure. Yes, and I just add a new enclosure. Just add a new enclosure. Yeah, enclosure 2. Generate. Oh, this is a box. Oh, that's not what I wanted to do. I want to add an enclosure of a sphere of a ball. Can I take 5 meters radius or cushion? And here again is my enclosure. And now the enclosure has also the geometry ranges of the plane. I rename it to enclosure again. Generate. Okay, that's again a pretty fine model. And I prove you will have better drag values here with this new design. Just close it. And the next step is to save it again. And I save it as design 2. Yeah. Where is it? Airplane design 1. Just take a new name, 2, because I've changed a bit of the design. And again, I have to do a meshing. I don't want to go into the meshing tool. I just want to reload it. I just do not want to open it. Wait a sec. Okay, so I have the green tick. The mesh is here. I have to go to edit again. And I have to reopen my setup screen just to check that the boundary conditions are right. Normally, yeah, you see that now we have some bugs here because I changed some planes, but that's not difficult, not a big problem. Yeah. Again, I look at the meshing. I have now one mesh, the B102, And the B, now he changed the name for the enclosure because I gave it, I recreated it. Now I have B 413. And I go back to default domain. I choose the B 413. Okay. I just now I just delete this airplane boundary and I just choose the surrounding here. It is probably, where is it? Here it is. Yeah, you have to search for it. It's a, and of course, these numbers will be different in your file. That's important. It will be different. And I rename this surrounding to airplane again. Okay, that's all I have to do. With the settings, I just keep the old settings. Go to close the screen, and please again now save it again. I changed something in the setup. Before I go to the next step, I want to save it. And now you have to clear the generated data here, and you have to update it. Go to update again. Wait a bit. We have to wait again. We can look into the monitor. It will start. At the beginning, the iterations are always a bit slow, yeah, because the numerical solution, the initialization is not so really good, yeah. You have some initialization of your field, and the solution is not so really converged, so you have a bit higher residual here at the beginning. But after some iterations, residuals should go down. And again, this red line is the residual for the numerical simulation of the mass balance, and the green and the yellow and the blue lines are the residuals for the solution of the Navier-Stokes equations. You see, something strange happens here after 20. That's really seldom. So residuals go upwards. Yeah, it's a bit strange. If you remember the last solution, it was a bit better. Yeah, the solution was this airplane with a round nose. The design one did not show this behavior of convergence. So the solver has a bit more work here. Maybe there's some swirl or some turbulent effect around the airplane. This can influence the numerical simulation, but now you see the problems are solved. Yeah, the residuals go down. They are 10 minus 4, 10 or 1 exponent minus 4. Oh, they go up again. That's a bit, yeah, maybe I can explain you what might happen if we now have this special nose. Yeah, maybe there are some fluctuations around the nose. Yeah, maybe we have some turbulent effects, some swirls of the nose, and this can influence also the simulation. But we are at least at 10 minus 4. Let's look at the, here you see turbulence. Turbulence is also high in this region, and it started at iteration 20. Yeah, something happened here, iteration 20. Maybe we can look into the out file here at 20. You see, there was also a scaling, time scale. I don't really know what happened, but doesn't matter. Now you see the convergence gets really down. Really, 10 minus 6 is a really good value. Yeah, it's nearly too good. I hope everything is all right. That's a perfect design, huh? Oh. Hmm. This simulation is a bit strange. I would say it's too good. You can also read this residuals. They're at 10 minus 6. They're, if you are at 10 exponent minus 6 or 1 exponent minus 6, then the simulation, the convergence is really, really good. Okay, doesn't matter. Your design is finished. Just close the design modeler. I go again to edit. And now you ask me to update. Yes, I want to reload the fresh. Huh? It didn't reload. Why not? Close it again. Open it again. Yeah. Now we have our new airplane at high altitude. You even see the sun here in this sky. And we see the design is much better. Yeah. You see the red area where you have this high pressure regions are much lower. Yeah. Can also render this in the tube a bit. Yeah. And you see here the fluid flow over the wing is how it should be. We have a longer way over the wing. We have this red high velocity region, and this will help a lot. And you even see you have some lift force here on the second wing. Okay, again, we go to our function calculator. Not the function calculator. And we want to calculate the forces of the airplane. And first we take Z direction. Z is interesting. It's a lift force. Yeah? We have about 2 million Newton, 2000 kilonewton in Z direction. And I want to know how much drag force we have. We can go to Y. Y is here's a Y direction, is a drag force. We calculate it, and we have again roundabout it's not so really good. It's not so much better. It's a bit better. Oh, okay, 10% better. Oh. In my opinion, it should be much better here because the red high pressure region is not so big anymore. But if you calculate this, it should be like this. Yeah. So just compare it, design. And I add lift force. And drag force of the second plane. Okay, so you see, I changed the nose a bit. The lift force went from nearly 2 million to 2.7. So we have better values in the lift, and the drag is now we have about 325 kilonewton, and here we only have 304 kilonewton. So around about 15% better. Okay, now I want to know it. Now I take my calculator. Now I want to know it. 3.4 divided by 325. Yeah, it's 7%. 7% by changing the design of the nose. We changed it around about 7%. Okay, guys, more or less, this is a presentation of our airplane design, and I think the design is pretty cool. Now you can do your own design, and Mr. Pink, we can finish the video, okay?